Chapter 1 Project Introduction. C is a programming language for computers. That is, you may write commands for a computer to perform using C. Moreover, C is one of tens of thousands many programming languages in use today. C was about for a long time and has gained general respect as a programming language that allows programmers the most flexibility and capability. C is a straightforward language to learn. It has a somewhat more complex syntax than certain other languages. However, you easily got further than that. Okay. C is a compiled programming language. This implies that when you have written your C programs, you will need to pass it over a C compiler to convert everything into an output that a computer could use. The form that human can read is the C program, whereas the machine can read an executable format is the output that goes out from the compiler. This means that in order to develop and launch a C program, you will need a C compiler. Since many compilers, JVMs, kernels, and other current programming languages are developed in C, and most programming languages such as C++, Java, and C# adopt C syntax. C is known the mother language among all high-level programming languages. It contains essential ideas such as arrays, strings, functions, file management, and so on, which are used in various languages such as C++, Java, C#, and so on. C is a programming easier than ever. We can set the device or machine to follow the step one by one by programming in it. Thus, we are assigned to help Mega Metal Company to improve their production planning. So we decided why not we implant the C programming into the machine or devices. The company mainly uses LED machine in their company, so to implant the C coding into it. Moreover, 3 programs will be implanted to make the step clearer and easier, thus to increase the productivity and efficiencies. Other than that, we will analyze and evaluate everything in terms of company standards and modern rules to make the company much more profitable and easy to handle without any troublesome. For example, steps involve total part machining time, total energy consumption, total operation cost, byproduct or solid waste generation in kg, and estimated productivity per 8 hours working will be included. Limitations, problems. To begin, we studied the traditional machinery and its process in our technical lab on our university, referring to internet information about the different traditional machine. Furthermore, we suggest a multiple structure that can be completed by the machines. Furthermore, we developed one full program for each of the machine to aid the operation in machining process planning, which is one program for one machine type with 3 different machines based on the proposed process. The total component machining time, total energy consumption, total operation cost, byproduct or solid waste creation in kg, and anticipated productivity per 8 hours of labor are all included in our program analysis. Finally, our application demonstrates the precise process and settings, as well as the exact calculations required to machine raw materials until the finished result is obtained. At first, many complication occurs. We are unable to code as the desired planning, but after few trial and error, we finally able to solve the program, and some might have some same errors that cannot be avoided, but we know we able to understand how C coding works. Conclusion. In summary, our project's objectives had indeed been met. We will be introduced to the coding software. We are able to grasp the operation of coding programs as a result of this effort. The Dev C+ program is simple to get. and capable of solving whatever programming, code, or system related issues. The C++ programming may be applied in the workplace. Next, we created C programs for the lab mission. Following that, variety of these C plus software related programs that required the same strategies could be handled. Lastly, this project will enable learners to develop their programming skills by teaching them how to design a flowchart that will allow them to comprehend the system. Thank you.
Hi, my name is Mugilan. Okay, today my topic is drilling machine introduction. Okay, drilling machine is the simplest, moderate, and most accurate machine tool used in almost all the production shops and tool rooms. Drilling is basically a single-purpose machine tool, as its main purpose is to make holes in the workpiece. A machine consists of a spindle that provides rotary motion to the drilling tool, which finally makes the hole in the job, the workpiece. Drilling machine working principle. Drilling machine has based upon the principle that the rotating edge of tool exerts a large force on the workpiece and holes are being created in the workpiece. The material is removed from the workpiece by the shearing and extrusion process. Drilling machine parts are the following parts: bed, pillar, swivel table, motor, step pulley, spindle, chuck, drill bit, and hand wheel. So these are the picture. So this is the motor elevating screw. This one is motor, feet handle. This one giving pressure to the workpiece, and drill head, spindle, drill. This one is base to put the workpiece here. Okay. Back drilling machine specification is the following specification of drilling machine are: the portable drilling machine is specified by the maximum diameter of the drill which can be held. Sensitive and upright drill machine are specified by the diameter of the largest workpiece that can be held. The radial drill machine is specified by the length of the arm and the column of the diameter. Multiple spindle drill machine is specified by the drilling area, the size, and the number of holes the machine can drill. Okay, these are the cutting speed and machining time of drill. Okay, cutting speed will be defined in the cutting speed equal to pi times by diameter of drill in millimeter times by rpm over 1000. So this is the machine time. T is time, L is length of the depth hole, M is rpm, F is feet per revolution of the drill. This one is minutes. Okay. The third one is L for length, H for height, for the drilling machine power calculation, T for torque, F for feet, D for diameter. Okay, we are selecting this part, which is five hole, one big hole and four small hole. Procedure and materials. The type of raw material that is used process is the steel plate because its machinability and steel has good strength, toughness, durability, and durability. Other than that, drilling steel will reduce less damage to the drill bit compared to other materials. That is will not affect the productivity of the design for a much longer time. First 30 mm hole is drilled at the middle of the steel by plate using 1.5 inches cobalt drill bit with spindle speed 300 rpm. Then the hole is enlarged by 40 mm by using boring process with 40 mm cobalt boring drill bit and a spindle of speed 1000 rpm. Four holes drilled at each corner with 5.5 inches diameter drill bit with spindle of speed 1000 rpm. Reaming process is done by each hole to smoother with 8 mm ramming bit with spindle speed 300 rpm. Two holes with opposite corner is countersinking with 5.5 inches bottom diameter, where the head size is 17 over 28-inch diameter with spindle speed 300 rpm. Two hole opposite a corner is counterboard with 17 over 28 inches head diameter with spindle speed 300 rpm. Parameter formulas. These are the parameter formulas. Okay, the steel plate parameter. Fixed parameter is length is 150 mm, width is 150 mm. Input will be thickness 10 mm to 14 mm between that, and price is the price of steel per kilo is 80 cents. Parameter for center hole drilling and boring. Fixed diameter, fixed parameter per spindle hole 300 rpm speed, and then depth of middle hole is thickness, radius of is 19, radius of boring is 20, input feet revolution per minute is all setting here. Here the formula is machining time formula. Okay, the machining ID is drilling depth, I is number of hole, N is spindle speed, FR is feet per revolution. The total energy consumption energy, the total energy equal to energy of motor plus energy of pump. Okay, estimated productive per day is 60 time machining time times by 8 hours. Solid waste generation, total volume equal to volume of middle hole plus 4 times whole volume of side hole plus 2 times volume of counter bore and 2 times of. Okay, these are the flow chart of the drilling machine, and these are the algorithms, and these are the C code, and these are the outputs.
Hello, my name is Haikal Haziq bin Harun, and I'll be presenting the CNC milling machine part. The selected machine and process has 5 processes, which is design parts, suitable materials, cutting tools, program input, and the machine itself. And this is a picture of the machine, the CNC milling machine, and here are the specifications, which is what the x-axis is 150 mm, 150 mm to 120 mm. These are all the specifications, and the appropriate material is then chosen after the specifications has been done, and the cutting tools are also chosen with care. The machine then receives a program input, which in figure 2 and figure 3 shows the specifications, and this is the flow chart for the machine. This is the selected part design, where the width of the piece is 600 millimeters, the length is 400 millimeters, and the thickness is 80 millimeters. The tiny circle is 60 inches in diameter, and while the larger circle is 300 inches in diameter. Both arcs have a radius of 50. And here is the parameters for the formula, which is, as you can see here, and here is the C codes. That is all on my part. Thank you very much.
Hi, my name is Kevin. So today I'm going to explain about the lathe machine. Okay, the lathe machine is a useful and vital tool. Okay, it is mainly used for cutting material to our desired shape and size. Okay, for the lathe machine description. Okay, these are the pictures for the lathe machine. Okay, we will place the material inside the spindle, which is near the headstock, and then we will place the tool bit towards the tailstock of the hand wheel. and then we will bring the tailstock towards the spinning spindle, and then this will cut or trim the material to its desired shape and sizes. Okay, these are the sophistication of the machines. Okay, for the part design we choose to do the thread like this for the raw material. Okay, for the operation analysis, before we do the C codings, the program for the machine, we will select the part, the appropriate material, the cutting tool, and the machine that we want to use, either lathe machine and so on. Okay, and then cutting metric and fine thread was chosen also. Okay, for these are the parameters and formulas. Okay, the length, rotation speed, total volume, machining time, number of cut, part machining, then material efficiency, area, output per day is generated, and utilization, number of starts. Okay, for this we choose LT300 machine. For this the highest spindle speed is 6000, the spinning length is 180 mm, the highest spinning length is 1050 mm, and then the processing. Okay, and then for this we have chosen cutting tool 45 HRC or nitride, the cutting speed of 60 meter per minute. And then these are the formulas that I mentioned, the parameters of the formula. So these are the formulas for the parameters. Okay, and then these are the flowchart. Okay, first we must find the limit of the diameter, maximum rotation speed, and the processor cap. Okay, and then these are the direction follow. Okay, this is the flowchart, and then we will stop at the end. Okay, and then these are the C codes. Okay, these are the outputs that we get. Okay, that's all from me. Thanks.